Hey guys, welcome to Unit 4, Section 4A, which is factoring polynomials. Now you're going to recognize a lot of the factoring techniques that we talked about in the last unit, but when we're factoring polynomials, we have higher degree polynomials than what we had before, because usually we were just working with quadratics. So if you look at this first example, common monomial factor is where we look at what can you take out of both terms. So we could factor this out as 8 and x plus 2. That's where we're just looking for the GCF. Then we have that difference of squares, which remember we talked about earlier, is just x plus 3, x minus 3. How do you get x squared? X times x. How do you get 9? 3 times 3. And then we have one of each sign. The perfect square trinomial, this is that pattern where it starts with x and x, and then we look at the last term. 9 is a perfect square, and factors of 9 that add to make 6 are 3 and 3. Signs are the same, both plus. And we could also write this as x plus 3 squared. So we've seen that pattern before. And then lastly, there's the general pattern where we look at two sets of parentheses, and then we get x and x. We look at the signs are both plus, so plus and plus. We're looking for factors of 6 that add to make 5, which would be 3 and 2. Okay, so that was when we were working with quadratics. So now let's look at how this is with something a little bit bigger. So these equations in example 2 are both quartic because the highest degree is 4, but we treat it the same way for this first problem. We look to see if there's a greatest common factor, can't take anything out. So if that doesn't work, let's do two sets of parentheses. Now, rather than having an x squared here, we have x to the fourth. So you have to think about, well, how do we get x to the fourth? And it actually comes from x squared times x squared. Then what we do is we recognize that signs are going to be different. The plus has got to be the bigger one. So we're going to get one positive, one negative. So we look at factors of 24 that have a difference of 5. Factors of 24 would be 6 and 4, 8 and 3, 2 and 12. But 8 and 3 are going to have the difference of 5, and it's going to be a positive 8 and a minus 3. All right? And we can't factor either of those any further, so we're actually done right there. Really not too different than what we've seen in the past. Let's try this one here. Again, always look for the GCF before we do anything, and you'll recognize that we can take a 2 out of both terms and an x squared. Then we're left with x squared minus 18 divided by 2 is 9, and the x's go away. Now this one we can take a step further because remember x squared minus 9 is that difference of squares. We get 2x squared times x plus 3 and x minus 3. So there's our answer for that one. Now some new factoring techniques that you haven't seen before. This is brand new, and we have to follow this pattern every time we see this situation. The first one is called the sum and difference of cubes. Here we're looking at the difference because we're subtracting. Notice this is the general equation up here. This is what we have to use every time. In the last video, there was a problem where you had to recognize what are the A, what are the B, and how does that work. So I'm going to show you what we do for this problem. First thing is identify what your A is and what your B is. So A cubed and B cubed are subtracting each other. 64x to the third power is actually a perfect cube. And that's, a cube is like a square, but it's a number times itself 3 times that would get you to that. 8 is also a perfect cube. And the numbers that we're going to use are 4x, because 4 times 4 is 16, and then another 4 would make it 64. So we get 4x, and then we also get 2. If you take 2 to the third power, we get 8. So that's what A and B are going to equal. Now what we're going to do is we're going to fill those in to this side of the equation. So A minus B is going to be 4x, because that's our A, minus B is 2. We're just substituting those out. Now we get to A squared, so that's going to be 4x squared plus 4x times 2, because it's A times B, plus B squared, which is going to be 2 squared. Now we just have to simplify. So 4x minus 2. Now we have to do this part here. Oh, sorry about that. Let's go back into OneNote. Okay, back to where we were. We have to square this part right here. When you square the 4, you get 16, and when you square x, you get x squared. Plus, now we have 4x and 2, which gives us 8x. And then we have 2 squared, which is 4. We can't actually go any further with the second parentheses. This is as far as we can go, so we're going to leave our answer right there. And that matches this form right here. So let's practice that with this next problem. 8y to the third minus 27. Again, you have to be able to recognize what's your a, what's your b. A, we start with the 8. We know that 8 comes from 2, because 2 to the third power is 8. And then y cubed comes from y. Then we get to b. 27 is also a perfect cube, and that comes from 3. 3 times 3 is 9, and then add another, or multiply by another 3, you get 27. So let's fill this out. We would get, remember we're going back to this equation over here. The first one is 2y minus 3. Then we get a squared, which is going to be 2y squared, plus 2y times 3, that's our a times b, plus 3 squared for the last part. Then we just simplify, nothing changes in the first parenthesis. This one is going to become 4y squared. We multiply 2y times 3, we get plus 6y. And then when you square 3, you get plus 9. And that's our answer right there. Really not a ton of work to it. It's just making sure that you understand where a and b come from and then getting the signs and the squaring correct. Now let's move on and let's try some with the difference or the sum of cubes. So this time notice it's a plus sign in between. We actually get a new set of equations. The only thing that changes though, compared to this one up here that we were talking about, the first sign is positive and then this sign here is negative. So we just got to make sure we put a negative and a positive where those need to be. All right, start out finding a. There's good old 8. We know that comes from 2. And x cubed comes from x. And then b. Now we have 27 is our b value. And we just did one with that. 27 comes from 3. So let's follow this side of the equation now. 2x is our a, plus b is 3. Now we have a squared, so 2x squared, minus 2x times 3, a times b, plus 3 squared. This one's going to look super similar to the one we were just working with, except there's going to be some signs that are different. We end up getting 2x plus 3, 2x squared is 4x squared, multiply these two together, but notice there's a minus sign out front, so it ends up being minus 6x, and then plus 9. And that's our answer right there. This is very similar to this. It's just a couple of signs are different, but they are technically different polynomials that we're factoring. All right, I'm going to do one more example, and then the last 3 are going to be yours to try on your own. 27x to the third plus 125. 27 we've already talked about. We know that that comes from 3. X cubed comes from x. And then b, in this case, is 125. So the number that we would cube to get 125 is actually 5. All right, let's go ahead and do this. It's going to be 3x plus 5. We're following our equation over here. A squared is going to be 3x squared minus 3x times 5 plus 5 squared. Now, if you are capable of recognizing the patterns right away, and you know that you're going to square 3x, you can go ahead and just write 9x squared. And then the second one would be minus 15x plus 25. If you can jump straight to this without having to write in the squares every time, you can go ahead and skip that step. But if not, I recommend writing that out. Okay, so basically these last three problems that you're going to do are just what I was talking about up above. Just make sure you look and see if it's a minus sign, plus sign, or a minus sign, because that determines which of the top two equations you use. Okay, so we use this one if we're subtracting, we use this one if we're adding.